Well, this will be our last example of free damped motion. Looks similar to the previous example. We have the natural length of the string here, and when at rest, the weight stretches that string 3.2 feet. So that is our S. And this is 16 pounds. This one is at rest right here. So the question is, if beta, our damping constant, is 1, and the initial position is -2, and the initial velocity is 0, find x of t, the function that tells the position at any time. Now notice what this means. X prime of 0 being 0, the velocity just means you're holding it in place and you're just letting it go. There's no external force that's giving it an initial speed. So it's released from rest, a resting position. Okay, well, F equals Ks. F is 16. K is what we're looking for. And the S is 3.2, and that tells us that K, the spring constant, is 5. And 16 is equal to mg. We want to find m. So we get 16 equals 32 times m, and m is equal to 1/2. So our generic second order free damped motion equation, this, now I'm going to plug in the known variables here. M is 1/2. d squared x dt squared plus beta, which is 1, so just plus dx dt. And then k is a 5, so plus 5x equals 0. So I'm going to write the characteristic equation right here. I just realized that I usually use m for the characteristic equation, and it has nothing to do with this mass variable here. So we get, well, first I'm going to multiply it all by 2. d squared x dt squared plus 2 dx dt plus 10x equals 0. Now we've got the coefficient of 1 for the second derivative term. Okay, so that means that m squared plus 2m plus 10 is equal to 0. How do we solve that? We don't know how to factor it, so I'm going to have to use the quadratic formula. M is equal to minus b plus or minus b squared minus 4ac would be minus 40 all over 2. That's equal to -2 over 2, which is -1, plus or minus, I'm going to just do a little bit of work over here. 4 minus 40 is -36, which is 6i. 6i over 2 is a 3i. So our two solutions are complex. So this is the third case. That would mean that the discriminant was less than 0, giving a negative number on the radical. So this means it's underdamped. I'll just make a note here, underdamped. That means it's going to oscillate quite a bit. All right. So I know that I know how to write the solution now because of this. Remember, that's our A and that's our B. A is -1, B is the exponent. It's going to be e to the 3t. So we get the solution. X of t is e to the -t. It's -1. Just times t, times, and here we get sines and cosines. Cosine 3t plus c2 sine 3t. I think I mistakenly said earlier that the 3 was the exponent of the e. It's the -1 that's the exponent of the e. So that's the general solution, and I think I want to go get the derivative now. Might as well. So let's get x prime of t. I've got that written down as e to the negative t times negative 3c1 cos 3t, oops, that'd be a sine, plus 3c2 cos 3t minus e to the minus t times c1 cos 3t plus c2 sine 3t. Okay, so now we've got xt and x prime of t. We can figure out what c1 and c2 are by plugging this in. So at time 0, the position x is negative 2. So I'll write x of 0 equals negative 2 implies that negative 2 is equal to. Now let's plug a 0 for t into this equation. E to the 0 is just a 1. c1 cosine 0, that's c1, plus c2 sine of 0 is 0. All right, so we've got c1 equal to negative 2. That was easy. And then x prime of 0 is a 0. So that gives us, plugging into this equation, we get 0 equals 1. Negative, that's going to be a 0 because sine of 0 is 0. This is going to be cosine of 1, which is a 1. Cosine of 0, which is a 1. So 3c2 minus e to the 0 is 1. C, let me put parentheses here just in case we need it. c1 times cosine of 0 is just a c1. But sine of 0 is 0. So I don't need those parentheses. So c1 is a negative 2. So 0 is equal to 3c2 minus negative 2. So that's really a plus 2. So negative 2 equals 3c2. And c2 is equal to negative 2/3. All right, so that gives us the final solution. I ran out of room, so I'm going to change colors and squeeze it in right here. Here's x of t, and we know c1 and c2. X of t equals e to the negative t. Negative 2 cos 3t, negative 2/3, or minus 2/3, sine 3t. That is the solution. And in case I didn't write it above, this is underdamped. You can remember that because this is the only one of the 3 possibilities. In this one, the discriminant, capital D, was less than 0 under the radical. So you get 2 complex roots. And that's the only case where you get sines and cosines. Sines and cosines are the ones that oscillate up and down.